Hi, dear students. Today we are going to finish lesson 10, and this is the last part of lesson 10 that we need to study. And this part will cover pages between 269 to 272. So today we are going to focus on carboxylic acid. Carboxylic acid, as you can see on the picture, the COOH. These actually four atoms together make a functional group, make a group in alkane or I mean um, uh, carbon chain or alkane is belong to carboxylic acid. Okay, these type of compounds ending with OIC acid, such as methanoic acid. This is can be used for naming of carboxylic acid. Each carboxylic acid ended up with OIC acid, like methanoic acid, ethanoic acid, or propanoic acid. So the first part is actually same with alkane. Okay, the alkane we learn that the first is methane, that means CH4, and ethane C2H6. So we need only add OIC, oic acid. So would be methanoic acid, ethanoic acid, something like that. So the most important part of carboxylic acid is the functional group of COOH. Okay, our carbon here, this carbon is belong to here, and it's connected with two bond, double bond with one oxygen is at this one, and also another carbon hydroxyl group OH is here. These R is carbon chain, is a carbonic chain, could be methane, ethane, or propane, and other carbonic chain. So the general formula of carboxylic acid is CnH2n plus 1 COOH, are similar, or here you need to put 2, but it's not different. Okay, it's not different. Can be read like CnH2n plus 1 CO2H. Both are correct. The first two acids means methanoic acid and ethanoic acid are liquid in room temperature. However, if you uh, reduce the temperature and give pressure, can be form of solid, can be solidified, and if you increase the temperature or in low temperature, I mean increase the temperature and low pressure, can be in form of gas. But in room temperature, actually its standard temperature is liquid. Okay, and very famous type of carboxylic acid, ethanoic acid, the second one, which is liquid also, and it's well known as acetic acid, is used in vinegar. The vinegar that we use it for cooking or cleaning, also many different purpose, is made of ethanoic acid or acetic acid. And all type of carboxylic acid, also called organic acid, because the the big part of this structure is organic. We learned before about um, metal acid. Okay, metallic acid actually, like one part of acid, acid actually is the compound which produce hydrogen ions here. Okay, we name a compound which can produce hydrogen ions, we call it acid. So metallic acid like uh, um, other compounds like NaH or halogen acid like HCl or other type, they produce more hydrogens, so uh, they would be a strong acid. But carboxylic acid is a type of weak acid because they produce less hydrogen ions in solution. Okay, so ethanoic acid, the second one, uh, which made up one, uh, two carbon actually. Totally, there are two carbon and CH3COOH, which is aqueous in the water, and it can when you dissolve it to the water, it can produce ethanoate ions, this one, the negative ions, and the positive, which is a hydrogen. But how we consider weak acid or a strong acid, as I said here, I put two type of picture. Here we have like ethanoic acid, which is known as a weak acid. If you look at the solution, only for example, one molecule can produce hydrogen ions, okay, positive proton, but the rest is still in the form of molecule structure, not ion structure. But on the other hand, you can see the hydrochloric acid is another type which is stronger, and it produces different ion in a solution in a water. Proton or positive ion, or actually it's a cation and an ion. Okay, an ion is a negative ion, which is chloride, and hydrogen ions, which is positive. They totally break down the molecule totally break down or dissociate to the solution. Here also I just put another picture in another form that you can see a strong acid like hydrochloric acid dissociate um, very well. They separate very well into ions, but this one, ethanoic acid, only some of the molecule dissociate to the ions. The rest still remain in a molecule form. Next slide, we are going to look at uh, some chemical property of methanoic acid and ethanoic acid. Methanoic is acid, meaning there is a methane, but they have a functional group of this COOH, which is um, symbol of, which is functional group of carboxylic acid. And the second one is ethanoic acid. The molecular formula is CH3COOH, and melting point increase and boiling point also increase when we increase the carbonic chain. Okay, we when we increase the carbon chain, I mean the number of carbon, so the melting point and boiling point increase. And another things is this picture, which is taken from your book, just to show you the molecular structure of methanoic acid, which there is one carbon, the black one is carbon, the white is hydrogen, and what we call the red one is oxygen. So this is methanoic acid, which is the simplest structure of carboxylic acid. The second one, ethanoic acid. We will have another uh, more carbon, and after that we have propanoic acid. There is two extra carbon, and botanic acid we will have another three more carbon. The totally four carbon. Okay, totally four carbon that carbon atoms. That's why we say butanoic, because it comes from butane. And the next one is the application of carboxylic acid. Carboxylic acids can be used as a descaler for hard water. We had a very short discussion about limestone. In some area, the people who use the water, what kind of water in the water is um, contaminate of limestone or calcium carbonate. So after a while of using this type of water in just some area, it depends on the land or the weather, something. So after a while of using this type of water in pot or kettle or tape, they get some calcium carbonate and limestone left on the surface. So if we can use vinegar to wash away these things, carbonate calcium, and also we can use ethanoic acid. I said ethanoic acid or acetic acid can be is used in vinegar to produce a vinegar, so you can use it in a pure condition, in pure solution, I mean, and then to wash away or remove uh, calcium carbonate or limestone. Limestone is another name of calcium carbonate. So, meaning that ethanoic acid can react very well with calcium carbonate. Okay, so then you will get water and also uh, carbon, what we call carbon dioxide in form of gas. So another application of carboxylic acid, another uh, thing that can be used is a reaction with base or neutralization. We learned this, I think, these reactions, this type of reaction in chapter which is belong to acid and base and also their reaction. You can see as we learned, ethanoic acid is one type of acid, but actually it's a weak acid. So, but still, it's able to react with sodium hydroxide or any other base. Sodium hydroxide is a strong base. Okay, so if ethanoic acid react with uh, sodium hydroxide, so we will get sodium ethanoate and water. One important reaction of carboxylic acid is a reaction between carboxylic acid and alcohol. We learned about alcohol at previous session. So the result from this reaction is ester. Ester is very important, and we are actually involving with esters for with many flavors or smells of flour, or the flavor that we can use for cooking or baking of sweets, many things. uh, they are all contain ester. Ester can be used in many different form. Here, for example, R is representative of carbonic chain. The carbonic chain can be here can be one carbon, either two, three, four, or any other carbon chain. Uh, can be methane, ethane, or propane, three carbon, four carbon, or which is butane. So here also can be carbon chain, and R also this argon can be another carbon chain, two different carbon chain. But you need to look at carefully for this reaction and see that these are O, RCO, and oxygen in ester. Okay, in ester RCO, this O comes from carboxylic acid. Only this argon replaced with hydrogen here, because we have learned that carboxylic acid is a weak acid and it produces hydrogen hydrogen cation, okay, our proton in the water. So when carboxylic acid leave the hydrogen, so this needs to receive another can receive another carbonic chain, which is argon here, from alcohol. So then it can be converted to ester form. The rest would be water. Water can be produced from the alcohol, which is only OH, okay, hydroxyl, after reaction, and also one hydrogen from carboxylic acid. One hydrogen from carboxylic acid and hydroxyl, I mean OH from alcohol, totally can be can create water molecules. So you need to analyze and look carefully for this reaction and see how ester produce and how water produce, and which part from the carboxylic acid and which part of from alcohol react to each other. Okay, I think yeah, that is for today, and this is the last part of this chapter. And please, we finish chapter 10. Please read carefully and many times on your book for more details. And I post more questions to review the chapters for getting more, becoming more skillful for IGCSE chemistry. Thank you so much. Take care.